This is Lesson 5A, Unit 11, Buffers, preparing a buffer solution. Again, we are using the pKa plus log A minus or over HA. These are problems where we're going to have to figure out how many grams we need, so it's a matter of making sure that we have moles for both the A minus and the HA. So let's take a look at our first problem. What mass of sodium formate must be added to 1250 mLs of 0.5 molar formic acid to make a buffer solution having a pH of 3.95? And here's our equation that we're going to be using. And to have our ratio of A minus to HA, we need moles of A minus and moles of HA. We can get our moles of HA from right here, our volume of 0.5 molar H2CO2. And then for the mass, what we need to find is the grams of the sodium formate. I've already calculated the pKa value that you need, so now we need to find our moles of HA. So we're going to convert the 1250 mLs to liters. So moles of HA would be 1.25 liters times 0.50 molar, and that's going to be 0.625 moles of H2CO2. Now we plug it into our equation. We have a target value of 3.95. So 3.95 is going to be equal to 4.74 plus the log moles of A minus, that's our sodium formate, over 0.625 moles of the HA. When we solve for that, we have negative 0.79 equals log, and A minus, I'm just going to leave A minus instead of moles, over 0.625. We're going to take the negative 0.79 and make that the exponent for 10, and that is moles of A minus over 0.625. And the moles of A minus that we need 0.101 moles of NaHCO2. And then you're going to use your periodic table, and the molar mass of the sodium formate is 68.008 grams per mole. And when we do sig figs, this is 6.9 grams of the sodium formate. Now, one of the common errors that students make, and I just made an error there, that should be a 2. Sorry, I don't have a eraser readily available. That's a 2 there. Is they solve for HCO2, forgetting that they have to include the mass of sodium when they calculate the molar mass here. Okay, let's take a look at the next problem. It is a parallel problem. So what you are going to do is you are going to pause the video, work the problem, and then I'll come back with the answer. Did you remember to convert Kb to Ka? If you didn't, stop the video again and try reworking the problem. Here is the completed problem. So the pKb was 8.74, therefore pKa has to be 5.26. These two will always add up to 14 at 25 degrees. Then we go ahead and plug everything in. We have the moles of A by taking 2 liters of the 0.3 molar A minus here, and that gives us 0.6 moles. Then we can plug it into our equation where we're going to solve for moles of HA. Simplify. Negative 0.23 is the log of 0.6 over moles of HA. Then we take this as the exponent, solve for the moles of HA. Moles of HA is 1.02 moles. The last thing we're going to do is to multiply our moles by the molar mass of this ammonium salt here. So we have to remember to include the mass of the chloride ion. And when we do that, we get 118. We should have only 2 sig figs based on 5.03. Remember, only our last 2 digits are significant. So our final answer would be 120 grams. Okay guys, I just found an error here. I have C6H5 and HCl. This should be C5 H5NHCl. So I've got it right up here and then I goofed up down here. My apologies.